Okay, let's talk about the section 7.2. Right triangle trigonometry. Right triangle trigonometry. Right triangle trigonometry. Right triangle. Let's see, we have a right triangle. Right triangle means this triangle has one right angle, 90 degrees, pi over 2 radian. The longest side, the side facing the right angle, is called the hypotenuse. Hypotenuse. And the other side, in this textbook, they're called the legs of the triangle. The two sides of the right angle are called the legs. And let's give them quantity. This is A, this is B, the hypotenuse is C. Then the Pythagorean theorem, the most important theorem in trigonometry. Pythagorean theorem. It says hypotenuse squared is equal to A squared plus B squared. Okay. If this angle is 90, then the total sum is 180, right? So let's put angle A, angle B. So angle A plus angle B plus 90 degrees is equal to 180 degrees. So you get A plus B equal to 90 degrees. So A plus B is equal to 90 degrees. So A is between 0 and 90, and B is also between 0 and 90. And those angles are called acute angle. So if theta is between 0 and 90, theta is called acute. Okay, so theta is acute angle. For the acute angle, let's see, you randomly pick any acute angle. You get this position, terminal initial, and you get one point, you do the right angle. You get a different point, you do the right angle. Then let's check. So here, let's assume this is A, this one is A prime, this is B, this is B prime, this is C prime. We just label the corresponding sides with the same letter, one without prime, one with a prime. And from the similar triangles, we know that, for example, A over B is equal to A prime over B prime, and A over C is equal to A prime over C prime, and B over C is equal to B prime over C prime. Whatever way, you can form 6 possible identities. 6, because you pick up 2 points from and form this ratio. You have 6 possibilities, or 6. Let's put a dot. Identities. There are 6 identities. Since they are always the same quantity, which means this ratio does not depend on the choice of this vertical side. You choose here, choose whatever place, you will have the same ratio. So this ratio is this ratio only depends on this angle theta, acute angle. It does not depend on this the large right triangle or smaller similar right triangle, right? So that's the reason we define the following 6 trigonometric functions. we start from acute angle. So this is a 6 trigonometric functions of acute angles. We have 6 because you have 6 different ratios. So theta is acute. You can put a theta between 0 and 90 degrees or theta between 0 and pi over 2. Okay, and then we define sine theta. Let me make this picture clear. This is A, this is B, this is C, this is theta. Sine theta is A over C. Cosine theta is B over C. And the tangent theta is A over B. Cotangent theta is B over A. And secant of theta is C over B. And the cosecant of theta is C over A. C over B, C over A. That's our definition. And you can see that there's no other way to form this ratio. There's no other way to form the ratio. And this one, you have to get the correspondence. You place this A facing theta, B is one side of theta, then you have this formula. If they change the letter, you have to change the corresponding expression. So in order to avoid this the selection of the letters, so what is a sine? Sine, when you have this angle, this is called the opposite side. Opposite of theta. This is hypotenuse, and this one is adjacent. Adjacent side. So A is opposite. So sine is opposite over hypotenuse. Hypotenuse. Opposite over hypotenuse. Cosine is the adjacent over hypotenuse. And the tangent is the opposite over adjacent. Cotangent, theta means theta is adjacent over opposite. And then secant theta is hypotenuse over adjacent. Cosecant theta is hypotenuse over opposite. Okay, so if you use this relative geometric position, then you can ignore, you can avoid the different formula by choosing different letters. Okay, so opposite over hypotenuse, adjacent over hypotenuse, and this is better. So for example, let's see. Assume we have this. It's a right triangle with a side 3, 4, 5. White is a right triangle. 3 square plus 4 square. It's 3 square is 9. 4 square is 16. It's 25. It's exactly 5 square. So 3 square plus 4 square is equal to 5 square. This is a right triangle by the Pythagorean theorem. So assume this angle theta is placed here, then 4 is opposite, 3 is adjacent, 5 is hypotenuse. So sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Cotangent theta is adjacent over opposite. The secant of theta is hypotenuse over adjacent. Cosecant theta is hypotenuse over opposite. Okay, so just memorize that as a tongue twister, and you repeat many times. You will get it. Okay. Okay, so that's an example. Once you get 3 sides of a right triangle, you can quickly determine the trigonometric values of the angle. And we have 6 trigonometric functions, and because we have 6 ratios, those ratios have a relation. So the relation is the following. You see, okay, cosecant opposite hypotenuse over opposite, sine opposite over hypotenuse. You just switch the top and bottom. So it means cosecant theta is a reciprocal of sine. Reciprocal of sine. Reciprocal identity. Reciprocal identity. Cosecant is 1 over sine. Secant, where is secant? Hypotenuse over adjacent. Adjacent over hypotenuse is 1 over cosine. And tangent, opposite of adjacent. Cotangent, adjacent over opposite. Cotangent is 1 over tangent. So you have 6 trigonometric functions, but in fact 3 of them depend on the other 3 by the reciprocal identity. Okay, so that's a very important observation. It just means we only need to study 3 of them. The other 3, you flip, you will get the properties, right? Okay. And another identity, this is reciprocal identities. You have 3 reciprocal identities. Another identity is a quotient identity. You check the tangent theta is equal to sine theta over cosine theta. Why? You see here, sine theta opposite hypotenuse, cosine theta adjacent hypotenuse. So sine over cosine is O over H, A over H. You multiply H on top and bottom. It's opposite over adjacent. Opposite over adjacent. That's exactly the tangent. This is a quotient identity. Right? It's quite simple. It's just you just directly get those properties from the definition. Just observe them. You will see the relation. The different. Here is a reciprocal identity. This is a quotient identity. Quotient identity. Okay, so let's see. Example. Given sine theta equal to square root of 5 over 5, cosine theta equal to 2 times square root of 5 over 5. Find the other 4 remaining trigonometric functions. Find the other 4 trig values. How do we find it? We just follow this property. So you have sine, you have cosine. So sine over cosine is a tangent theta. It's a square root of 5 over 5 over 2 times square root of 5 over 5. Root 5 over 5, root 5 over 5. You cancel the same term, you get 1/2. Okay, so tangent is 1/2. Now let's continue this. And we continued by the reciprocal. So cosecant is 1 over sine. So just flip the 1 over sine. 5. Remember, any integer is square root of the integer and squared. So 5 is a square root of 5 squared. So 5 over square root of 5 is just square root of 5. Secant theta, you switch them, so it's a 5 over 2 square root of 5. 5 over 2 square root of 5 is root 5 over 2. And cotangent theta is 1 over tangent. The reciprocal of 1/2 is 2. So we get 1, 2, 3, and 4 values. Okay, so you start from the sine and cosine. You compute the tangent. When you get the sine, cosine, tangent, you flip them. You get the other 3 trigonometric functions. Okay. Remember the Pythagorean theorem: a squared, b squared, c squared. And if we divide it by c squared, we will get a squared over c squared plus b squared over c squared is equal to 1. Or a over c squared plus b over c squared is equal to 1. A over b squared adjacent over hypotenuse is cosine theta squared. B over c is the opposite over hypotenuse is a sine theta squared is equal to 1. So this is the identity we have. Sine squared plus cosine squared is equal to 1. And in the trigonometric functions, we write sine theta to whatever power as sine theta to nth power. So we don't write this parenthesis, but we put this power on the shoulder of sine, on this symbol, function symbol, not on the variable symbol. Okay, so this is a sine theta to nth power. So with this symbol in mind, we can write cosine squared plus sine squared equal to 1 in this way. So be careful about this. If you really want to put power on top of a input, so you have to write it this way. This one is different from that. They are not equal to each other. Okay? So be careful about the place of power n. Okay, start from the sine squared cosine squared is equal to 1. If we divide the two sides by cosine theta squared, so every term you divide by cosine theta squared. So it is equal to 1 plus sine theta over cosine theta squared is 1 over cosine theta squared. And sine over cosine is tangent. 1 over cosine is secant. So from here we get our second formula. 1 plus tangent theta squared is equal to secant theta squared. This is a process. See. We got this formula by dividing the identity by cosine theta squared. If we divide it by the sine theta squared, we will get the other one. So that's the other two most important identities. So let me summarize it here. We have 3 square equal to 1. So first, sine theta squared plus cosine theta squared is equal to 1. This is a fundamental one. It comes from Pythagorean Theorem directly. And then you divide it by cosine squared divided by sine squared, you have 2 equivalent formulas. 1 plus tangent theta squared is a secant squared, or 1 plus cotangent theta squared is a cosecant theta squared. These 3 formulas are equivalent, but we always start from sine squared plus cosine squared equal to 1. Right? Let's see. For example, if we want to compute tangent 20 degrees minus sine 20 degrees over cosine 20 degrees. Sine 20 over cosine 20 degrees is tangent 20 degrees. And 20 degrees minus 20 degrees is 0. So there's nothing left. And B, if you have sine pi over 12 squared plus 1 over secant pi over 12 squared. Remember, secant, cosine, they are reciprocal to each other. 1 over secant is cosine, 1 over cosine is secant. Okay, so once you have a pair of reciprocals, you flip one, you get the other one, always. And once you have sine pi over 12 squared plus cosine pi over 12 squared, it's by the Pythagorean theorem is equal to 1. Okay. Now let's see. We not only have the relation between sine, cosine, tangent, and other cotangent, secant, cosecant. We not only have those relations, we also have the relation between sine and cosine, right? So now let's see the example. Let theta be acute and sine theta is 1 over 3. Sine theta is 1 over 3. Let's try to find other 5 trigonometric values. The last example, in the previous example, we have 2 trigonometric values. We're looking for other 4. And here we only have 1 trigonometric values. We're looking for other 5. So this one is even harder than the first example. So how do we do that? It's acute angle. Acute angle, just draw it in the right triangle. And sine is 1 over 3. You just assume opposite is 1, hypotenuse is 3. It's okay. You can assume opposite is 10, hypotenuse 30. It's the same thing, but you just make the computation more complex. Okay, so you assume the opposite is 1, hypotenuse 3 because you have sine. The sine is the opposite of hypotenuse, and you assume the adjacent side as a. Then by the Pythagorean theorem, a squared plus 1 squared is equal to 3 squared. So a squared plus 1 is equal to 9. A squared is 8. So a is square root of 8. So you get the adjacent square root of 8. Square root of 8 is also 2 times square root of 2. How do you get it? 8 is 4 times 2. Square root of 4 times 2 is square root of 4 times square root of 2. square root of 4 is 2. So it's 2 times square root of 2. Okay, once you get the missing quantity adjacent side, so what are the other 5 trig values? Cosine adjacent over hypotenuse, sine is given, and tangent is opposite over hypotenuse. And you get sine, cosine, tangent, then cosecant. The other 3 are reciprocal of them. Cosecant is 1 over sine. And secant is 1 over cosine. Cotangent is 1 over tangent. Okay. So this is the answer of the problem. And be careful, you have to assume the angle theta to be acute in order to put it in the right triangle. Okay, so let's see another example, similar example. Given theta acute and tangent theta equal to 1/2. Find other 5 values, trigonometric values. Fine. Okay, then it's a similar thing. So tangent opposite over adjacent, opposite over adjacent. So opposite side is 1, adjacent side is 2. Then hypotenuse, you miss hypotenuse. Hypotenuse square is the sum of squares of legs. 1 square plus 2 square is equal to c square. 1 square is 1, 2 squares is 4. The sum is 5. So c is square root of 5. We're talking about the geometry. The geometry, all the quantities are positive. So you only need the positive square root. That's enough. You have hypotenuse, you have 2 legs, and what's the rest? So sine theta, opposite over hypotenuse. Cosine theta, adjacent over hypotenuse. Tangent theta, opposite over adjacent. You have those 3, then the other 3 are the reciprocals. Cosecant, reciprocal of sine. And secant, the reciprocal of cosine. Tangent, cotangent, reciprocal of tangent. Okay, so that's how other values. Right? It's cool. Okay, so let's continue the discussion of this acute in this right triangle, remember we already discussed that A plus B, the sum of those 2 angles is 90 degrees. Whenever the sum of 2 angles are 90 degrees, AB are acute. Then we call A and B are complementary. They're complementary if the sum is right angle. Okay, for this position, let's check for sine of B. Sine B opposite over hypotenuse. But if you consider the angle A, B is adjacent over hypotenuse. Hypotenuse is always hypotenuse. For angle B, this side B is opposite, but for angle A, side B is adjacent. So adjacent over hypotenuse is cosine. Okay, and the cosine of B is adjacent over hypotenuse. it becomes opposite with respect to angle A, so it's a sine. So sine B is cosine A, cosine B is sine A. And similarly, tangent of B, tangent B over A, opposite of adjacent, it is equal to B over A, and it is also equal to cotangent of A. Cotangent A is adjacent over opposite. Because they they change the position, they have different positions, so they have different corresponding opposite and adjacent. So they really switch each other. Cotangent of B, A over B, is tangent of A. And secant of B. Secant is hypotenuse over opposite. It is hypotenuse over adjacent. It's a cosecant of A. And the cosecant of B is a hypotenuse. Secant is hypotenuse over adjacent. That's my bad. Hypotenuse of adjacent. Here is hypotenuse of opposite. Hypotenuse of opposite. Right. It's a secant of A. Here's C over A. Okay, so these 6 identities actually give us what? Give us a complementary angle theorem. The complementary angle theorem says the following. Co-functions of complementary angles are equal. Sine is cosine, secant is cosecant, tangent is cotangent when you change the change between the complementary functions. Okay? So whenever you have sine theta, it is equal to cosine. If you get cosine, you need its complementary. Its complementary is always 90 degrees minus theta or the pi over 2 minus theta, because the sum of them is pi over 2 or 90 degrees. Okay, so when you change it to its complementary, you put co, or you remove the co function. You see here, this is cosine of theta. It's a sine pi over 2 minus theta. Here you have a co, then you have to remove it. If you don't have a co, you put it. So tangent of theta is cotangent pi over 2 minus theta. Cotangent of theta is tangent pi over 2 minus theta. And secant of theta is cosecant of pi over 2 minus theta. And the cosecant of theta is secant of pi over 2 minus theta. Just exchange between function and the co-function. Okay? For example, if we have sine 62 degrees, it is equal to cosine 28 degrees, because 62 plus 28 is 90. And if we have a tangent pi over 12, it is equal to cotangent, what's this, 5 pi over 12, because 5 pi over 12 plus pi over 12 is exactly pi over 2. Let's see, if we have cosine pi over 4, it is equal to sine pi over 4. This one is a special case. Pi over 4 plus pi over 4 is pi over 2. 45 plus 45 is 90. d cosecant pi over 6 is secant of pi over 6 plus pi over 3. Pi over 6 plus pi over 3 is pi over 2. So they are complementary. So cosecant, secant, they're corresponding to each other. Okay? So this is the examples. So in this section, we have 6 trigonometric functions. Don't memorize the definition by ABC. Don't memorize the definition by ABC, because ABC, they may be labeled differently from book to book, from problem to problem. Okay, so that is not a reliable notation. Memorize opposite, adjacent, and hypotenuse. Opposite over hypotenuse, sine. Adjacent over hypotenuse, cosine. Opposite over adjacent, tangent. Okay, 3. You only need 3 functions, and that's enough. And the other 3, you just flip sine, cosine, tangent, you will get the other 3. And then you have sine squared plus cosine squared equal to 1. That's trig identity. And from that, you get 1 plus tangent squared is equal to secant squared. 1 plus cotangent squared is a cosecant squared. And then you have this complementary angle theorem. You get the corresponding complementary angle. You change between the function and its cofunction. Okay, so there are many formulas in this section. Do the exercise, try to memorize those formulas. If you have any questions, send me an email. Very good, and we'll stop this video and we will continue another video. Thank you.